Hey guys, tonight we're going to do something a little different. Close your eyes if you feel comfortable, and let's go on a journey not to the stars, but to a place equally vast and mysterious, the Sahara Desert. Imagine with me the feel of the sun-baked air on your skin, a fine dust, a whisper of 1,000 forgotten stories carried on a gentle breeze. You're standing on a seemingly endless ocean of sand, the horizon, a shimmering line where the earth meets an impossibly blue sky. It's a landscape of raw, magnificent emptiness, a place that seems to hold its breath. This is the heart of our story. We're going to ask a question that feels both audacious and deeply human. What if we terraformed the Sahara Desert? It's an idea that touches on a kind of magical thinking, the desire to turn a whisper into a shout, to make the impossible bloom. But a gentle warning, my friend, a journey like this in the real world would probably be a bit sandy. You'd be covered in it in your hair, in your clothes, and maybe, just maybe, you would not survive the first night. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. As you settle in, let me know where you are in the world tonight and what time it is for you. Share a quiet moment with me. And now, let's let the great silent landscape of the Sahara begin to speak. We begin with the sheer incomprehensible scale of the Sahara. It's a sea of sand and rock so immense that it defies easy description. To call it a desert is like calling the ocean a puddle. It is a continent-spanning canvas stretching over 9 million square kilometers, an area roughly the size of the United States. Think about that for a moment. Picture the map in your mind. From the Atlantic coast to the Red Sea, from the foothills of the Atlas Mountains to the savannas of the Sahel. It is a single, uninterrupted testament to the power of heat and aridity. For us to even begin to consider terraforming it, we must first truly grasp its size, not just in numbers, but in our imagination. We must see it not as a blank space on a map, but as a living, breathing, and impossibly complex entity in its own right. The sand itself is a story told in grains, each one a tiny polished gem of quartz or feldspar, a fragment of a mountain range long since weathered away by wind and time. The dunes, some of them hundreds of meters high, are not static monuments, but living things migrating across the landscape with the seasons carried on the breath of the wind. This is not a project we could simply start and finish in a human lifetime. To terraform the Sahara would be an undertaking so vast that it would span generations. It would require the kind of long-term thinking that is almost alien to our modern world. It would be a conversation with a sleeping giant, and our first words would need to be very, very careful. The very first question isn't about what we would do, but what we would need to know. We would need to become students of the land itself, learning its rhythms, its secrets, and its silent history. To understand this, let's step back and consider a core scientific concept that underpins all of our grand ambitions: thermodynamics. At its simplest, thermodynamics is the study of energy and how it moves and transforms. It's about heat work and the inevitable flow of things from order to disorder. The Sahara is a thermodynamic machine of immense power. It is a massive solar collector, absorbing a tremendous amount of energy from the sun every day. This energy heats the land, which in turn heats the air above it, creating a powerful convection current. This rising hot air is a key player in the global atmospheric circulation that we'll touch on more later. The Sahara's heat and dryness are not a flaw in the system. They are the system. Our first task would be to change this fundamental energy equation. We'd have to find a way to cool the surface to introduce moisture and to store that energy in a different way, perhaps through the photosynthesis of new plant life. The mythical allure of a green Sahara is an old story. It's a kind of human dream, a deeply rooted desire to turn wasteland into garden. But to begin, we must move beyond the dream and into the difficult, beautiful reality of the numbers. Consider the water. Where would it come from? The Sahara is surrounded by the vastness of the Atlantic and Indian Oceans. The most obvious and most audacious idea would be to use seawater. But the amount of water needed to not just irrigate, but to fundamentally alter the climate is staggering. A simple calculation reveals the immense challenge. If we were to flood a significant portion of the Sahara, say, a basin the size of the Baudelaire Depression in Chad, we would need to transport a volume of water that is almost unimaginable. The Baudelaire Depression is about the size of the state of Massachusetts. Now imagine filling it with seawater to a depth of just a few hundred feet. That is a massive engineering project, a project that would require canals and pumping stations of a size and scale that dwarf anything we have ever built. The energy required to pump that water would be astronomical, and the salinity of the resulting lake would be a whole new challenge for our fledgling ecosystem. It would be an act of both creation and destruction, turning a desert into a saltwater sea. The scientific truth is that simply adding water is not enough. You can't just water a desert and expect it to become a forest overnight. The soil itself is often devoid of the organic matter and microbial life necessary to support a complex ecosystem. It's a paradox. You need the life to create the soil, but you need the soil to support the life. This raises an interesting question. Is terraforming a purely technological problem, or is it more of a biological one? Can we simply build our way out of the desert, or do we have to grow our way out patiently? Cultivating a new world from the ground up. The allure of the Sahara, even in its current state, is undeniable. It is a place of profound silence and deep mystery. It holds secrets beneath its shifting sands, remnants of ancient rivers and lost cities. One of the strangest and most compelling scientific facts about the Sahara is the existence of the Risha structure in Mauritania, often called the Eye of the Sahara. From space, it looks like a massive 40-kilometer wide bullseye. For years, scientists thought it was an impact crater. But the prevailing theory today is that it's a deeply eroded geological dome, a testament to the slow, relentless power of geological processes. It's a natural wonder that reminds us of the vast timescale of the desert, a timeline that dwarfs our own fleeting existence. Our plan to terraform would be a new line of text, written on a page already filled with a long, complex, and beautiful story. To succeed, we must not seek to erase this story, but to become a small part of it. We must learn to speak its language, a language of sun and wind, of ancient rock and shifting sand. We must become stewards, not conquerors. And this, I believe, is the first and most important philosophical step of our journey. We are not here to impose our will, but to enter into a dialogue with the land itself. We must listen to the whispers of the sleeping giant before we dare to wake it. It is a delicate dance, a conversation between the transient ambition of humanity and the deep abiding patience of the earth. A terraformed Sahara would not be a new world. It would be a very old one, brought back to life by a new kind of magic, the magic of science, patience, and a quiet respect for the land. This profound scale and the initial challenge of water bring us to the very edge of our comfort zone. We are accustomed to thinking in human terms, a decade, a century. But the Sahara operates on a timescale of geology and climate, a pace that makes our lives feel like a fleeting breath of wind. Terraforming, at its core, is a project of patience. We would have to seed the desert with life, not with a bulldozer, but with a whisper. This would involve a painstaking process of introducing pioneer species. These are the first organisms to colonize a new environment. On our hypothetical Sahara, these would be hardy, salt-tolerant plants and microbial life, a kind of biological vanguard. They would begin the slow, arduous work of breaking down the mineral-rich sand into soil, a process that could take centuries. They would capture the first few drops of moisture, hold the first grains of sand in place, and begin to alter the microclimate of their immediate surroundings. It's a concept similar to how volcanic islands are born. First, a sterile rock emerges from the sea, Then, over eons, it is slowly colonized by life, a process of succession that eventually creates a lush ecosystem. The simple act of introducing life would have cascading effects. The dark green leaves of these pioneer plants would absorb sunlight, changing the surface's albedo or reflectivity. The white bright sand reflects a great deal of the sun's energy back into space. A dark green forest would absorb that energy, warming the air above it, but also using it for photosynthesis. This stored energy would be a kind of biological battery fueling the growth of more life. This shift in albedo is a crucial piece of the puzzle, a quiet domino that could start a chain reaction. The warming air would rise, but it would also carry with it the water vapor released by the plants through a process called evapotranspiration. This is the key. It's the mechanism by which a forest can, in a sense, create its own rain. The water that evaporates from the soil and is transpired through the leaves of the plants creates a local cloud cover. This cloud cover, in turn, shades the ground, cools the temperature, and brings back moisture in the form of rain. A single pioneering plant might seem insignificant, but when you multiply it by billions, you are creating a new engine of climate, a new heart for a land that has lain dormant for millennia. But what would be the first plant? What would be the first organism brave enough to face this new world? This is where the science becomes as much an act of careful curation as it is of grand design. We would have to look to the most resilient forms of life on Earth. Perhaps some species of succulents from the Atacama, or deep-rooted grasses from the Australian outback. We might even have to engineer new forms of life plants specifically designed to thrive in a hostile saline environment. This raises a philosophical and ethical question that will follow us on our entire journey. When does terraforming become an act of creation? And when is it an act of genetic modification on a planetary scale? Are we playing God, or are we simply being good gardeners? The answer, perhaps, is that it is both, and so we must end this first part of our journey with a deep breath and a quiet acknowledgement of the task ahead. We have only just dipped our toes into the vast sandy ocean of this idea. We've considered the scale, the thermodynamics, the water, and the first whispers of life. But we have not yet touched on the currents that run through the world's oceans, the great rivers of salt and warmth that connect every corner of the globe. We haven't considered the way the Sahara's change would echo across the entire planet's atmosphere. These are not isolated systems. They are a single interconnected dance. And so, as you drift further into your thoughts, let the silent, heat-hazed image of the desert fade and prepare to dive into the deeper, darker mystery of the sea. The ocean, which seems so far away, holds the key to the Sahara's future, and our next chapter will be about its hidden heart. Last time we stood on the immense, sandy canvas of the Sahara, a place so vast and so old, it feels like a memory of the planet itself. We spoke of its thermodynamics, its silent heat engine, and the daunting scale of our human ambition. We also touched upon the immense challenge of water, the paradox of needing life to create the soil, but soil to support the life. As the last grain of sand settles in our minds, let's turn our gaze now to a place that seems to be its polar opposite, the deep, cold heart of the Atlantic Ocean. For the truth is, the desert and the deep sea are not separate worlds. They are intimately, profoundly connected by a single invisible thread, the great oceanic currents. Our grand experiment of terraforming the Sahara would not be a local affair. It would send ripples across the globe, and the very first place we would feel those ripples in a major planetary way would be in the Atlantic Ocean. The key player here is a magnificent, slow-moving river within the sea, a kind of planetary conveyor belt known as the Atlantic Meridional Overturning Circulation, or AMOC. Imagine a single continuous current that acts like a global circulatory system, a beating heart for the planet's climate. It works on a simple principle of temperature and salinity. Near the equator, the sun heats the surface water, making it less dense. This warm water flows northward, carrying its thermal energy towards the poles. As it moves north, it cools and becomes saltier due to evaporation. By the time it reaches the North Atlantic near Greenland and Iceland, it's so cold and dense that it sinks to the ocean floor. This cold, deep water then begins a slow journey back south, completing the loop. It is a subtle, powerful, and utterly vital system. The AMOC is what keeps much of Europe warmer than it would otherwise be, and it plays a critical role in distributing heat around the entire globe. Without this warm northward flow, much of the northern hemisphere would be a much colder place. So how does this relate to the Sahara? The Sahara in its current state is a major source of dust. Every year, billions of tons of fine dust are lifted from the desert by winds and carried across the Atlantic. This isn't just a simple matter of wind and sand. It's a global phenomenon. This dust, known as the Saharan air layer, travels thousands of kilometers crossing the ocean and settling in places as far away as the Amazon rainforest. A less-known scientific fact is that this dust is a vital source of nutrients. It contains phosphorus and other minerals that fertilize the Amazon's nutrient-poor soils, helping to sustain one of the most biodiverse ecosystems on Earth. The dust from the Sahara is the Amazon's lifeblood. It's a humbling reminder of the interconnectedness of our planet. The desert, which seems so barren, is in fact a silent engine of life for a distant, lush jungle. But what would happen if we turned the Sahara green? What would happen if we silenced the great dust engine? The AMOC would change, of course, but the way it would change is a matter of profound scientific mystery. The newly green Sahara, with its vast new forests, would create its own regional climate. There would be more rainfall, more cloud cover, and more fresh water flowing into the surrounding seas. This influx of fresh water, which is less dense than salt water, could disrupt the sinking process of the AMOC. If the surface water in the North Atlantic becomes less salty and less dense, it may not sink with the same force, or it might not sink at all. The entire current could slow down or even stop. This isn't a new idea. We know from paleoclimatology, the study of ancient climates, that the AMOC has slowed and even shut down in the past, leading to dramatic and rapid climate shifts. The consequence of a weakened AMOC could be a colder northern hemisphere with profound implications for agriculture, weather patterns, and the very stability of our human societies. This brings us to a core concept in the study of complex systems, the idea of tipping points. A tipping point is a critical threshold where a small change can lead to a large, irreversible shift in the state of a system. The AMOC is a classic example of a system with potential tipping points. A slow, gentle influx of fresh water might have a negligible effect, but a sustained, large-scale change, such as that which would be caused by a terraformed Sahara, could push the system past its point of no return. We might, in our quest to create life in one place, inadvertently trigger a cascade of events that would fundamentally alter the climate of the entire planet. We don't know for sure, of course. We can run our models. We can make our best guesses. But the truth is, the full scope of such an intervention remains a haunting mystery. The Earth's climate is not a simple machine with a single on and off switch. It is a delicate tapestry, and if we pull on one thread too hard, we risk unraveling the entire thing. The philosophical implication here is a humbling one. Our desire to fix a problem in one part of the world might create a new and perhaps more dangerous problem in another. The idea of terraforming the Sahara is often presented as a conquest, a victory of human ingenuity over a hostile environment. But the reality is that the Sahara in its wild and untamed state is not hostile. It's simply part of a much larger global system. Its function as a dust factory for the Amazon, its role in the planetary energy budget, its silent conversation with the currents of the ocean, these are all parts of a whole. To change one part, even with the best of intentions, is to change the whole. And the Earth, in its profound and ancient wisdom, might not be as forgiving as we'd like to believe. The ocean with its deep memory would be the first to tell us so. The ocean remembers the shifts in the ice ages, the changes in the flow of the currents, the slow march of continents across the globe. It holds a record of our planet's history in its chemical composition, in the layers of sediment on its floor. To alter the amok would be to write a new, perhaps tragic line in that ancient book, and so we must look at our task not just as an engineering problem, but as an act of profound ecological responsibility. We are no longer just asking, can we do it, but should we do it? The answer to the second question is tied to our understanding of the planet as a single living organism, a concept first put forth by the chemist James Lovelock in his Gaia hypothesis. The Gaia hypothesis suggests that living organisms interact with their inorganic surroundings on Earth to form a synergistic and self-regulating system that helps to maintain the conditions for life on the planet. The Sahara, the Amazon, the AMOTER, they are all part of this self-regulating system. To intervene in one part of it is to intervene in all of it. A terraformed Sahara might be a beautiful, vibrant ecosystem, but if it came at the cost of a freezing Europe and a collapsing Amazon, would it be a price worth paying? The question is a profound one, and it reminds us that our story is not just about human ambition, but about our place in a much larger, more mysterious story. A story that the ocean has been writing for billions of years. One of the more fascinating and less known scientific facts about the ocean is the presence of oceanic dead zones. These are areas in the ocean with extremely low oxygen content, so low that most marine life cannot survive. They are often caused by nutrient runoff from human agriculture. The nutrients, such as nitrogen and phosphorus, fuel the growth of massive algal blooms. When these algae die, they sink and are decomposed by bacteria, a process which consumes oxygen. The result is a vast, sterile area of water, a ghostly silence in the midst of the bustling ocean. Our hypothetical terraforming of the Sahara, with its vast new agricultural potential and its massive engineering projects, would inevitably create new flows of nutrients into the sea. Would we create new dead zones? Would we, in our attempt to bring life to one part of the world, bring death to another? These are not small questions, and they serve as a powerful reminder of the delicate and fragile nature of the planetary systems we are attempting to manipulate. The ocean, with its deep and powerful currents, is a mirror that reflects the consequences of our actions, and it is a mirror we must look into with great care and great respect. The very scale of the ocean is another thing we must ponder. It holds over 97% of all the water on Earth, a volume so great it is difficult to comprehend. The average depth of the ocean is about 3.7 kilometers. To think of our terraforming project as something that would only affect the land is to be profoundly mistaken. The land and the sea are two parts of a single equation, two sides of a single coin. Our ambition would be like trying to change the texture of a single leaf and expecting the entire tree to remain the same. It would not. The tree would feel it, and it would respond. And the ocean, the great, slow, patient heart of the earth, would feel our work most of all. It would register every drop of fresh water, every change in temperature, every new dust particle, and it would respond in its own slow, magnificent, and utterly indifferent way. Its response would not be a judgment. It would simply be a consequence. And we, the architects of this new world, would have to live with that consequence. As you drift further into your thoughts, let the image of the desert fade and let your mind sink into the deep, dark, silent world of the ocean. The journey continues, and it is a journey into the heart of a system far older and far more powerful than we can ever fully comprehend. The whispering sands have now given way to the deep, silent currents of the sea, and we must listen carefully to what they have to say. We have journeyed from the silent, sun-baked surface of the Sahara to the deep, slow-moving rivers of the Atlantic Ocean. We've seen how these two seemingly distant landscapes are connected, how the dust from the desert fertilizes the rainforest, and how the deep-sea currents act as a kind of planetary heartbeat. As we move our attention from the water to the air, we'll see how this dance of connection becomes even more intricate and more profound. The atmosphere is not a uniform blanket. It is a complex, turbulent ocean of gas, and within it, a different kind of choreography. Takes place the intricate ballet of global air currents. The Sahara in its current state is not just a passive receiver of sunlight. It is a powerful engine that drives large-scale atmospheric circulation. The intense heat absorbed by the desert surface creates a massive column of rising hot air. This is the simple principle of convection. Hot air rises, cool air sinks. This rising air creates a zone of low pressure at the surface. To fill this vacuum, cooler, denser air from the surrounding regions rushes in. This creates the powerful and consistent trade winds that have been a cornerstone of human navigation for centuries. These winds, in turn, are a crucial part of the Hadley cell, a global atmospheric circulation pattern that stretches from the equator to roughly 30 degrees latitude. Warm, moist air rises at the equator, travels towards the poles, cools and sinks back to the surface at these latitudes, creating the high-pressure zones that are home to many of the world's great deserts, including the Sahara itself. The Sahara is not a mistake of this system. It is a fundamental pillar of it. It's a kind of self-sustaining cycle. The high-pressure system creates the dry conditions, and the dry conditions, with their intense solar absorption, help to maintain the high-pressure system. So what happens if we change this? What if we were to terraform the Sahara to replace the heat-absorbing sand with a vast green forest? A forest, unlike a desert, would absorb less solar radiation. Remember the concept of albedo from our first chapter. But it would also introduce a massive new source of moisture into the air through evapotranspiration. Evapotranspiration is a core concept here. It's the combined process of water evaporating from the land and transpiring from the leaves of plants. It's the engine of a local water cycle. This new moisture-laden air would rise, but it would have a very different effect than the dry, hot air of the desert. The moisture in the air would condense to form clouds, which would reflect sunlight and create rainfall. This would cool the surface, alter the pressure systems, and fundamentally disrupt the Hadley cell. The very engine that helps to create and sustain the Sahara would be dismantled and replaced by something else entirely, a new green engine that creates moisture clouds and rainfall. This disruption would not be contained to the Sahara. The atmospheric circulation patterns of the entire planet would be affected. The great ribbon of rising air at the equator would shift. The powerful jet streams, the fast-flowing narrow air currents high in the atmosphere, would change their paths. This could lead to unpredictable and massive shifts in weather patterns across the globe. A less-known scientific fact is that the jet stream is not a single static entity. It meanders and shifts, and these shifts can cause extreme weather events. A stalled jet stream, for example, can lead to prolonged heat waves or cold snaps, a phenomenon that has been observed more frequently in recent years. Our terraforming project, by fundamentally altering one of the planet's great atmospheric engines, could cause the jet stream to shift in new, unpredictable ways, leading to new and extreme weather patterns on a global scale. We don't know for sure what the full scope of these changes would be. The truth is, the atmosphere is a chaotic system, and small changes in one part of it can have massive, non-linear effects in another. This is where the idea of teleconnections becomes important. A teleconnection is a recurring and persistent, large-scale pattern of pressure and circulation anomalies that spans vast geographical areas. A classic example is the El Niño Southern Oscillation NAHO, a climate pattern in the Pacific Ocean that has far-reaching effects on weather across the globe. The terraforming of the Sahara would create a new kind of teleconnection, a connection between the newly green desert and the rest of the world's atmosphere. The new weather patterns over the Sahara would not just stay in the Sahara. They would send waves of atmospheric change rippling across the planet, affecting rainfall in the Amazon, snowfall in the Himalayas, and hurricane frequency in the Caribbean. We might solve a problem in one place and, inadvertently, create 100 new ones in 100 other places. The mystery is not just what the effect would be, but how we could even begin to model and predict it. The complexity of the atmosphere with its billions of interacting particles and its immense scale is beyond the grasp of even our most powerful supercomputers. The philosophical implication here is that our planet is not a collection of isolated regions, but a single interconnected system. To change the Sahara is to change the world. It's a humbling thought, a reminder of our place in the grand global choreography of nature. We are not just actors on a stage. We are part of the scenery itself. The atmosphere is a kind of global commons, a shared resource that we all depend on. The air we breathe in our quiet, safe homes has traveled thousands of miles, carrying with it the dust of the Sahara, the salt from the ocean, and the pollen from distant forests. To interfere with this ancient system is not just an act of engineering. It is an act of planetary stewardship, and it carries with it a profound ethical responsibility. The question is not whether we are capable of making such a change, but whether we are wise enough to do so. The mystery is not just in the science, but in ourselves. Are we ready to accept the consequences of our own ambition? The atmosphere, with its vastness and its turbulence, is a kind of theater for the invisible forces that shape our world. The wind is a story told in motion. A gust of wind on your face in the morning might have been born a week ago in a different hemisphere, a different climate. It might have traveled over mountains and oceans, over cities and forests, carrying with it the memory of its journey. The terraforming of the Sahara would not just change the land, it would change the very breath of the world. It would be a new act in a very old play, a new symphony for the wind to play. And just as the ocean holds its secrets in its deep currents, the atmosphere holds its secrets in its subtle movements. The truth is, we don't fully understand all the forces at play. We are still in many ways just beginning to learn the language of the winds. One of the more peculiar scientific facts about atmospheric circulation is the existence of the polar vortex, a large rotating mass of cold air that sits over the Earth's poles. While not directly linked to the Sahara, its behavior is profoundly linked to the jet stream and the overall health of the planetary circulation. When the jet stream is stable and strong, it acts as a kind of wall containing the cold air of the polar vortex. But when the jet stream becomes wobbly and weak, it can allow the cold air to escape and travel south, causing extreme cold snaps. A terraformed Sahara, by altering the global atmospheric circulation, could have a ripple effect that destabilizes the jet stream, leading to more frequent and intense polar vortex outbreaks. This is an example of a chain of events so complex that it is almost impossible to fully predict. It's a reminder that every part of our planet is a component in a grand and sometimes terrifying machine. We are not just changing the Sahara, we are in a sense tinkering with the entire machine. And the machine has been running beautifully for billions of years without our help. So as we bring our thoughts to a close on this part of the journey, let's take a moment to simply listen. Listen to the quiet rustle of the air around you. It is a part of a global conversation, a dialogue between sun and land, between ocean and sky. And our terraforming project would be a new voice in that dialogue, a voice that could bring with it both harmony and discord. We have looked at the land, the sea, and now the air. Our next step is to look at the most fundamental building block of all, the rain. The symphony of clouds and water is waiting for us, a story of how a single drop of water can begin to write a new future. So let the winds of the Sahara fade from your mind and let the gentle whisper of a coming rain take its place. We've traced the invisible threads that connect the Sahara to the ocean and the atmosphere, from the deep, patient currents of the Amok to the vast, meandering jet streams. We've seen how the desert is not an isolated landmass, but a critical player in a global drama. Now let's turn our attention to the most beautiful and fundamental part of this entire system, the water cycle. Imagine with me, not just the rain, but the entire elegant symphony of water, rising from the earth, forming clouds and returning once more. This is the heart of our story, the moment when our hypothetical terraforming project truly begins to take shape. The hydrologic cycle, or water cycle, is the continuous movement of water on above and below the surface of the earth. It's a concept we learn in grade school, but its complexity and power are truly humbling. Water evaporates from oceans, lakes, and rivers, rising into the atmosphere as a gas. It then condenses into clouds, travels with the wind, and returns to the ground as precipitation, rain, snow, or hail. It is the very lifeblood of our planet. The Sahara, in its current state, is largely outside this cycle. With little standing water and no widespread vegetation, it contributes very little moisture to the air. The vast majority of its incoming solar energy is used to heat the ground, which in turn heats the air, creating a hot, dry, and stable high-pressure system. Our plan to terraform would fundamentally change this. By introducing water, whether by massive canals from the sea, desalination plants, or a combination of both, we would be giving the Sahara a new powerful voice in the global water symphony. The first effect would be local. The new bodies of water we create, whether they are small lakes or massive inland seas, would begin to evaporate. This would introduce water vapor into the air, a key ingredient for forming clouds. But the true engine of change would be the new plant life we would cultivate. As we discussed, pioneer species would begin to grow, and these plants would release moisture into the air through a process called transpiration. This is the subtle, silent breathing of a forest. A single tree can transpire hundreds of liters of water in a single day. Now imagine a forest spanning millions of square kilometers. The sheer volume of water vapor released into the atmosphere would be astronomical. This brings us to the science of cloud formation. For a cloud to form, you need three things: water, vapor, a drop in temperature to a point of saturation, and cloud condensation nuclei. These nuclei are tiny particles, dust, pollen, sea salt, even pollution, that provide a surface for water vapor to condense around. A less-known scientific fact is that the dust from the Sahara itself, which we discussed fertilizing the Amazon, also acts as a vital source of these cloud condensation nuclei over the Atlantic. A terraformed Sahara would dramatically reduce this dust. While this might be a good thing for air quality, it could also have unforeseen consequences for cloud formation in distant parts of the world. It's another example of how our grand, beautiful idea in one place might have a strange and unpredictable ripple effect in another. With the new source of moisture from our green Sahara, and with the cooling effect of the clouds themselves, a new and self-sustaining weather pattern would emerge. The air above the newly green desert would be cooler and more humid than the air above the surrounding desert regions. This would create a new kind of pressure system, a low-pressure system that would draw in more air, and most importantly, more moisture from the oceans. This is the positive feedback loop we've been waiting for. The more the desert greens, the more moisture it produces, the more clouds it forms, the more rain it receives, which in turn allows for more plant life to grow. It is a virtuous cycle, a kind of planetary regeneration. The Sahara would stop being a passive sun-baked landscape and become a powerful, active participant in the Earth's climate system. The philosophical implication of this is profound. We would not be simply watering a dead landscape. We would be giving it the tools to heal itself. We would be nudging a great ancient system back into a different state of equilibrium. It's a powerful idea, a testament to the resilience of nature itself. We are not creating a new world out of nothing. We are, in a sense, helping an old world remember what it once was. We know from geological and archaeological records that the Sahara has not always been a desert. Just a few thousand years ago, it was a green and vibrant landscape, dotted with lakes and teeming with life. This brings us to a deep and fascinating question that scientists still grapple with: what causes these massive planetary scale shifts in climate? Is it the slow, predictable march of astronomical cycles? Or is it the delicate, unpredictable dance of atmospheric and oceanic forces? The truth is, we don't really know for sure. The mystery of the Sahara's ancient past is a part of the mystery of its potential future. The new weather patterns would also have a direct impact on human life in the region. The people who live on the edges of the Sahara in places like the Sahel have always lived a precarious existence dependent on the often unpredictable rains. A green Sahara would bring new stability, new opportunities for agriculture, and a new kind of security. But it would also bring new challenges. We would have to manage this new water, to build new infrastructure, and to create new societies in a place where only sand and rock once existed. It's a grand vision, but it is a vision that would be fraught with immense logistical and social challenges. Who would own the land? Who would control the water? These are not just scientific questions. They are questions of politics, ethics, and human nature itself. A fascinating and somewhat counterintuitive scientific concept related to this is the idea of atmospheric rivers. These are long, narrow corridors of concentrated moisture in the atmosphere, thousands of kilometers long, that are responsible for the vast majority of our extreme rainfall events. They are essentially rivers of water vapor flowing in the sky. Our newly green Sahara, with its immense new source of moisture, could spawn new atmospheric rivers, sending waves of rainfall to distant parts of the globe, bringing both life-giving rain and the potential for destructive floods. It's a powerful reminder that our intervention is not a clean, simple solution. It's an act of profound planetary modification, and the consequences would be as beautiful and creative as they would be unpredictable and potentially destructive. We would be playing with forces so vast and so powerful that our human-scale understanding of them would be profoundly inadequate. So as we let the image of the clouds and the coming rain settle in our minds, let's take a moment to reflect on the nature of this change. It is not an act of conquest, but an act of invitation. We are inviting the Sahara back into the global conversation of water and life. We are creating the conditions for it to remember its past, to once again become a green and vibrant land. But we must do so with humility and with great care. The symphony of clouds and water is a delicate one, and our role is not to command it, but to listen to it and to become a quiet part of its beautiful, unending melody. The winds of the desert are now filled with the promise of rain, and our next chapter will be about the long, slow, patient memory of the sun and the subtle astronomical forces that have been shaping the Sahara for billions of years. We've now witnessed the genesis of a new weather system over our green Sahara, a self-sustaining cycle of evaporation, cloud formation, and rainfall. This symphony of clouds and water is our imagined present, but to truly understand its significance, we must look backward in time. The Sahara is not a fixed, immutable desert. It has a memory, and that memory is written in its ancient riverbeds, its cave paintings, and its geological history. Our next chapter is about this memory, about the paleoclimatological history of the Sahara and the subtle, magnificent forces that have shaped its fate for eons. We'll explore the idea that our terraforming project, in a way, is simply a return to an older, greener state. The key to understanding the Sahara's ancient past lies in a core scientific concept known as the Milankovitch cycles. These are not a single phenomenon, but a trio of subtle, predictable changes in the Earth's orbit and orientation relative to the Sun. Imagine our planet not as a perfectly stable sphere, but as a top spinning in space. Its spin slightly wobbly, its orbit slightly elliptical, and its tilt slightly variable. Over tens of thousands of years, these wobbles and tilts change. Specifically, there are three primary cycles: the eccentricity of Earth's orbit, the obliquity of its axial tilt, and the precession of its axis. The eccentricity cycle describes the shape of Earth's orbit around the Sun, which shifts from a more circular to a more elliptical shape and back again over a period of about 100,000 years. The obliquity cycle refers to the tilt of the Earth's axis, which varies between 22.1 and 24.5 degrees over a 41,000-year cycle. This tilt is what causes our seasons, and a greater tilt means more extreme seasons. The precession cycle is the most complex. It's a slow wobble of the Earth's axis, like a spinning top that's losing momentum. It changes the timing of the seasons relative to our position in orbit, and it repeats every 26,000 years. These three cycles working in concert are the primary drivers of long-term climate change. They don't change the total amount of sunlight the Earth receives, but they do change its distribution across the planet and across the seasons. A less-known scientific fact is that these cycles were the key to the Sahara's past. About 10,000 to 5,000 years ago, during a period known as the African Humid Period, the Sahara was a green and vibrant land. This was a direct result of the Milankovitch cycles. At that time, the Earth's orbit was configured in a way that led to a stronger African monsoon. The monsoon is a seasonal wind pattern that brings heavy rainfall. The stronger monsoon pushed deep into the Sahara, creating a network of rivers, lakes, and savannas. Evidence of this green past is everywhere if you know where to look. There are rock art sites in the middle of the desert that depict giraffes, hippos, and other animals that are now only found far to the south. There are layers of sediment in ancient lake beds that show a history of flourishing aquatic life. The Sahara was not always a desert. It was once a lush, living landscape, a fact that serves as a powerful testament to the power of these astronomical cycles. Our terraforming project, in a way, would be an act of artificial Milankovitch cycling. We would be using human ingenuity to replicate the conditions that the Earth itself created naturally thousands of years ago. We would be, in a sense, using technology to rewind time to restore a landscape to its former, more vibrant state. This raises a profound philosophical question. Is there a moral difference between a climate shift caused by natural forces and a climate shift caused by human intervention? Is the end state of a green Sahara a morally good thing, regardless of how we get there? The truth is, we don't have a clear answer. The ethical waters here are as murky as a monsoon flood. The Sahara's past is not just a scientific curiosity. It is a memory of a different world, a world where our species was just beginning to find its footing. The people who lived in the Green Sahara were hunter-gatherers and pastoralists. They left behind a record of their lives, not just in rock art, but in the subtle changes they made to the landscape, the hearths they built, and the tools they left behind. A terraformed Sahara would be a new chapter in this long human story. We would be returning to a place that our ancestors once called home, but we would be returning with a different kind of knowledge, a different kind of power. We would be returning as architects, not just as inhabitants. The gradual drying of the Sahara, which began about 5,000 years ago, was a slow and relentless process. As the Milankovitch cycles shifted, the African monsoon began to weaken. The lakes and rivers began to shrink, the grasslands gave way to sand, and the people and animals were forced to migrate south. It was not a sudden catastrophe, but a slow, inexorable change that unfolded over centuries. A fascinating and somewhat mysterious scientific fact about this period is that the transition from a green Sahara to a desert was not a smooth linear process. There were periods of rapid abrupt change, what paleoclimatologists call tipping events. These were moments when a gradual change in a forcing factor, like a shift in the monsoon, pushed the system past a critical threshold, leading to a rapid and dramatic shift in the climate. The system essentially snapped into its new state. This is a powerful lesson for our terraforming project. We might be able to create a new green Sahara, but the transition could be a period of immense instability and unpredictable changes, a kind of wild, untamed chaos before a new equilibrium is reached. So as we let our minds drift back from the sun's ancient memory to our own present moment, let's hold on to this thought. The Sahara has been a green land before. Our ambition is not to create something entirely new, but to help a magnificent patient landscape remember its past. The sun, with its slow, predictable dance, has given us a blueprint. Our challenge is to see if we can follow that blueprint, not with the patient eons-long rhythm of the cosmos, but with the fast, ambitious rhythm of human ingenuity. We have looked at the land, the sea, the air, and the water cycle. Now we have looked at the sun's ancient memory. Our next step is to get our hands dirty, to dig into the ground itself, and to explore the very blueprint of life, the creation of soil, and the slow, patient process of building an ecosystem from scratch. We have now traveled through time from the grand quiet rhythms of the Milankovitch cycles that once made the Sahara green back to our present moment of ambition. We have contemplated the vastness of the land, the depth of the sea, the currents of the air, and the symphony of water. Now it is time to get our hands dirty, to move beyond the grand planetary scale ideas and down to the fundamental building block of all life, the soil. Our next chapter is about the very blueprint of life itself, the painstaking, meticulous process of creating a new ecosystem from the ground up, a process known as ecological succession. A desert, at first glance, seems to have no soil. It has sand and it has rock, but it is largely devoid of the rich, dark, life-giving substance we call soil. Sand is, in essence, just weathered rock. It lacks the organic matter, the intricate web of microbial life, and the complex nutrient cycles that make soil a living thing. To transform the Sahara, we cannot simply irrigate the sand. We must create a new kind of earth. This is where the science of soil creation comes in, a slow, patient, and beautiful process that would be at the very heart of our terraforming project. We would have to introduce a kind of biological vanguard, a group of organisms known as pioneer species. These are the most resilient and hardy forms of life, the first to colonize a new and barren environment. On our hypothetical Sahara, these pioneer species would have to be incredibly tough. They would have to be able to survive in a high salinity environment, as our initial water source would likely be desalinated seawater, which still retains a certain level of salt. They would have to be able to handle extreme heat and intense sunlight. We would likely turn to organisms like certain species of drought-resistant grasses, salt-tolerant halophytes, and perhaps even specially engineered microbial life. These organisms would begin the slow, arduous work of breaking down the sand and rock, using their roots to crack open mineral fragments and their metabolic processes to create the first precious bits of organic matter. They would be the first to die, but in their death, they would give life to the next generation. Their decaying leaves and roots would become the first humus, the dark, rich organic component of soil. This brings us to the core concept of ecological succession. It's the process by which a biological community evolves over time from a simple pioneer community to a complex, stable ecosystem. It's a journey from barrenness to abundance. The first stage, which we just described, is called primary succession, and it's the beginning of everything. After the pioneer species have done their work, the new, slightly more hospitable soil would be able to support a new kind of life. We would introduce new, hardier species, shrubs, nitrogen-fixing plants, and early forms of animal life like insects and birds. These new species would in turn continue to enrich the soil, adding more organic matter and creating a more complex web of life. The shade from the new shrubs and trees would cool the ground, hold moisture, and create a microclimate that would allow for even more delicate and diverse forms of life to take hold. A less-known scientific fact about soil is that a single teaspoon of healthy soil contains more microorganisms than there are people on Earth. This microbial life, the bacteria, fungi, and archaea, is the true engine of the soil, a kind of invisible, silent factory that breaks down organic matter cycles, nutrients, and forms the very structure of the soil itself. We could not simply create soil. We would have to cultivate this microbial life. We would have to introduce specific strains of bacteria and fungi that are essential for plant growth. For example, some species of fungi form a symbiotic relationship with plant roots, creating what are known as mycorrhizal networks. These networks act as a kind of underground communication system, a web of nutrient exchange that helps plants to thrive even in nutrient-poor conditions. Our terraforming project would be as much about cultivating these invisible networks as it would be about planting trees. It's a powerful reminder that the grand beautiful forest we envision is built on the silent microscopic work of a world we can't even see. The philosophical implication of this is a humbling one. We are not just planting seeds. We are initiating a conversation with a world we don't fully understand. We are starting a process that will take centuries to unfold, a process that we will not live to see the end of. The idea of ecological succession is a beautiful metaphor for life itself, a reminder that from every death new life is born, and that from every struggle a new kind of strength can emerge. The first plants to die on our new Sahara would not be a failure. They would be the first crucial step in a long, patient, and magnificent journey. This is where the concept of secondary succession comes in. Once an ecosystem is established, even if it is disturbed by a fire, a flood, or even human activity, the soil remains. This allows a new and much faster process of regeneration to begin. The seeds and microbes that survive the disturbance are able to rapidly regrow a new ecosystem. Our goal on the Sahara would be to get to a point where this kind of secondary succession is possible, to create an ecosystem that is so resilient and so self-sustaining that it can heal itself from any disturbance. This would be the true mark of success, the moment we have moved from being the architects of a new world to being its quiet, respectful stewards. The long-term success of our terraforming project would depend on our ability to manage this process of ecological succession. We would have to be patient, to learn from our failures, and to adapt to the unexpected. We might find that some species we introduce do not thrive, that others become invasive, or that the process unfolds in a way we never could have predicted. The truth is, we are not in full control. We are a part of a larger, more complex system, and we must learn to listen to its subtle rhythms and its quiet wisdom. The Sahara has been waiting for this moment for thousands of years, and its story is far older than ours. Our role is not to impose our will, but to help its ancient memory reawaken. And so, as we leave the blueprint of life and the slow, patient process of succession behind, let's prepare to confront the next great challenge of our journey, the unforeseen consequences, the subtle, invisible effects of our grand, audacious experiment. We've traced the slow, patient work of ecological succession, watching as pioneer species begin to weave a new tapestry of life into the Sahara's sandy canvas. But as we move forward, we must now confront the shadow that follows every grand ambition, the unforeseen consequences. Our grand project, born of the best intentions, would be an act of profound and irreversible change. Our next chapter is about the ghost in the machine, about the hidden variables and nonlinear effects that could turn our carefully laid plans into a chaotic, unpredictable mess. To understand this, we must turn to a core concept of modern science: chaos theory. Chaos theory is the study of complex systems that are highly sensitive to initial conditions. It is famously summarized by the metaphor of the butterfly effect, where a butterfly flapping its wings in Brazil could over time cause a tornado in Texas. The point of chaos theory is not that everything is random, but that in certain systems, the relationship between cause and effect is so complex and so intertwined that it is impossible to predict the long-term outcome. The Earth's climate is a classic example of a chaotic system. The atmosphere, the oceans, and the land are all connected in a web of feedback loops and nonlinear relationships. A small change in one part of the system can over time be amplified into a massive global shift. Our terraforming project would be a very large, very deliberate butterfly, and the consequences of its wing beats would be utterly unknowable. So what are some of these unseen consequences? We've already touched on a few. The change in the Sahara's albedo, or reflectivity, would alter the global energy budget. The disruption of the Sahara air layer, which fertilizes the Amazon, could have a devastating effect on a distant ecosystem. But what about the effects that we haven't even considered? The terraformed Sahara, with its vast new forests, would become a new source of atmospheric moisture. But what if this moisture, combined with other atmospheric conditions, led to the formation of new kinds of storm systems? What if the new humid air created by the Sahara became a breeding ground for supercell thunderstorms, or even something more powerful and more destructive than anything we have ever seen? The truth is, we don't really know for sure. The atmosphere is so complex that our computer models, while powerful, are still only approximations of reality. There is a deep and profound mystery here, a sense that we are opening a door without knowing what lies on the other side. The philosophical implication of chaos theory for our project is a humbling one. It forces us to confront the limits of our own knowledge and our own power. We are accustomed to thinking in linear, predictable terms. If we do X, then Y will happen. But in a chaotic system, X can lead to Y, or it can lead to Z, or it can lead to a million other things that we never even imagined. Our grand plan is built on the assumption that we can control the outcome, but the reality is that we can only influence the initial conditions. The universe, in its magnificent indifference, will take our initial push and run with it, creating a future that is entirely its own. We would not be the masters of this new world. We would be its unwitting midwives. This raises a fascinating and somewhat unsettling question. Is our ambition to terraform the Sahara a testament to our ingenuity, or a testament to our hubris? Is it a beautiful act of creation, or a foolish gamble with a system we barely understand? The answer, perhaps, is that it is both. A less-known scientific fact is the existence of strange attractors in chaotic systems. A strange attractor is a set of values toward which a system tends to evolve even when it is in a state of chaos. Imagine a storm. While we can't predict the exact path of every raindrop, the storm as a whole follows a general pattern, a path that is predictable within certain bounds. Our terraformed Sahara might create a new stable climate, a kind of strange attractor, but the path to get there could be a wild and unpredictable journey, a journey filled with extreme weather events, unforeseen ecological crises, and a level of chaos that would challenge our ability to adapt and survive. The system would eventually settle into a new state, but the transition would be a wild, untamed ride. It's a powerful reminder that our journey is not just about building a new world, but about surviving the messy, unpredictable process of its birth. The ecological side of this chaos is equally daunting. When we introduce pioneer species, we are not just adding plants. We are starting a new food web, a new dance of predator and prey, of competition and symbiosis. We might introduce a plant that we believe to be harmless, only to find that it becomes an invasive species, outcompeting the native plants and creating a monoculture. We might introduce an insect to control a certain pest, only to find that it has an unforeseen effect on a distant ecosystem. The classic scientific example of this is the introduction of the cane toad to Australia, which was meant to control a beetle, but instead became a devastating pest itself. Our terraforming project on a much larger scale would be a series of such introductions, each one a roll of the dice. We would be playing with the invisible threads of an ecosystem, and the consequences would be as unpredictable as the butterfly's wing beat. And so, as we let the idea of chaos theory settle in our minds, let's take a moment to acknowledge the deep, profound mystery that underpins our entire project. We are not just building a new world. We are intervening in a system that is far older, far more complex, and far more powerful than we can ever fully comprehend. Our grand, beautiful plan is not a blueprint for a finished product, but a set of initial conditions for a chaotic, unpredictable future. The ghost in the machine is not an enemy to be defeated, but a fundamental part of the system itself. And we, the architects of this new world, must learn to be humble in its presence. We must learn to listen to the chaos, to adapt to the unexpected, and to be ready for a future that is not just of our own making, but a co-creation with the magnificent, unpredictable forces of the universe. Our next step is to look at the even deeper memory of the Sahara. Not in its climate, but in its ancient geology, the unspoken conversation with the past that is written in its rocks and its mountains. We have journeyed into the swirling, unpredictable world of chaos theory, confronting the humbling reality that our terraforming project, no matter how well planned, would unleash a cascade of unforeseen consequences. We've considered the butterfly effect of our actions, the limits of our knowledge, and the profound mystery of a system we can only partially comprehend. Now let's turn our attention to an even deeper, more patient aspect of the Sahara, its geology. The desert holds an unspoken conversation with the past, a story of continental drift, ancient seas, and buried mountains. Our next chapter is about this conversation, about the deep time of geology, and how our human-scale ambitions would write a new fleeting line on a page already filled with a long, magnificent narrative. The Sahara is not just a landscape of sand. It is a geological record written in rock. Underneath the shifting dunes lies a foundation of ancient bedrock, a testament to a world that existed hundreds of millions of years ago. The core concept here is plate tectonics, the scientific theory that describes the large-scale motion of the plates that make up Earth's outer shell. The African continent, like all continents, is a massive plate, and over geological time, it has drifted, collided, and been shaped by these immense, slow-moving forces. The Sahara itself is a tapestry of different geological formations, each one a memory of a different era. There are ancient mountain ranges, long since weathered down to low hills, that speak of past continental collisions. There are vast basins once filled with shallow seas that now hold layers of sediment. The desert, in a sense, is a kind of geological graveyard, a place where the bones of a different world lie waiting to be discovered. Our terraforming project would not just be an act of human will, it would be an act of geological modification. The new heavy weight of vast lakes and forests would press down on the Earth's crust, a phenomenon known as isostasy. This is the principle that a heavier load on the crust causes it to sink, and a lighter load causes it to rebound. The immense weight of a new inland sea, for example, would cause the crust beneath it to slowly sink over thousands of years. Conversely, the melting of a continental ice sheet causes the crust to rebound, a process that is still happening today in parts of Scandinavia and North America. Our terraforming project would be a human-induced isostatic change, a kind of geological whisper that would be heard over millennia. The land itself would respond to our presence, a slow, patient, and powerful conversation between our ambition and the Earth's deep memory. A less-known scientific fact about the Sahara is that it is home to some of the world's most dramatic geological wonders, including the Tassili N'Ajjer mountain range in Algeria. This area is a kind of open-air museum of geology with surreal rock formations that have been sculpted by wind and sand over millions of years. It also contains one of the most important collections of ancient rock art in the world, a silent record of the time when the Sahara was green. These rock formations, with their intricate patterns and their silent stories, would still be there after our terraforming. But they would be a part of a different world. They would be a memory of the desert, a kind of ghost in the new machine, a testament to the fact that nothing is ever truly erased, only transformed. Our project would write a new chapter, but it would not be the first, nor would it be the last. The philosophical implication of this is a humbling one. We are so used to thinking of the Earth as a static backdrop for our lives. But the truth is that it is a dynamic living system that is constantly in motion. The mountains we see today were once seabed, and the seabed of today will one day be a mountain. Our terraforming project, in the grand scheme of geological time, would be a fleeting moment, a kind of geological footnote. The Earth has been through much more dramatic changes than a simple greening of the Sahara. It has been covered in ice, it has been a steaming jungle, and it has been a single supercontinent surrounded by a single global ocean. The Sahara, with its deep and ancient memory, has seen it all. Our challenge is to see ourselves not as the masters of this system, but as a small temporary part of a much larger, more magnificent story. The truth is, we don't fully understand the full subtle power of these geological forces. We are still, in many ways, just beginning to learn the language of the rocks. This conversation with the past would also be an archaeological one. The shifting sands of the Sahara have hidden countless secrets, lost cities, ancient trade routes, and the remnants of civilizations that have long since faded from memory. A terraformed Sahara, with its new lakes and rivers, would uncover some of these secrets, but it would also bury others forever under layers of new sediment and new life. It's a kind of paradox. In our quest to bring new life to the desert, we would inevitably destroy some of the old. The history of the Sahara, both human and geological, would be irrevocably altered, a new story written over an older, more beautiful one. The ethical question is, do we have the right to do this? Is our desire for a green Sahara worth the loss of an ancient unwritten history? The answer, perhaps, is that there is no simple answer. And so, as we let the image of the rocks and the deep memory of the earth settle in our minds, let's take a moment to reflect on our place in this vast ancient conversation. We are not just building a new world. We are intervening in a system that is far older, far more complex, and far more powerful than we can ever fully comprehend. Our grand beautiful plan is not a blueprint for a finished product, but a set of initial conditions for a chaotic, unpredictable future. The ghost in the machine is not an enemy to be defeated, but a fundamental part of the system itself. And we, the architects of this new world, must learn to be humble in its presence. We must learn to listen to the chaos, to adapt to the unexpected, and to be ready for a future that is not just of our own making, but a co-creation with the magnificent, unpredictable forces of the universe. Our next step is to look at the even deeper memory of the Sahara, not in its climate, but in its ancient geology, the unspoken conversation with the past that is written in its rocks and its mountains. We've now journeyed through the deep memory of the Sahara, a place where the bones of ancient mountains and the echoes of continental drift tell a story of immense geological time. We've seen how our terraforming project would be a new fleeting line written on this ancient page, a conversation with a past far older than our species. Now let's leave the scale of continents and millennia behind and zoom in all the way down to the quiet, microscopic architecture of life itself. Our next chapter is about the most fundamental process on Earth, the very engine that powers our planet, photosynthesis. We will explore how the introduction of vast new plant life to the Sahara would alter the global carbon cycle, transforming the desert into a powerful new lung for the planet. Photosynthesis is a concept we all learn early, but its elegance and power are truly humbling. At its core, it is the process by which plants, algae, and some bacteria convert light energy into chemical energy, creating sugar from carbon dioxide and water. It is the fundamental process that sustains almost all life on Earth, from the smallest blade of grass to the mightiest redwood. Photosynthesis is the ultimate act of creation, the way the world builds itself from the light of a distant star. The Sahara, in its current state, is largely outside of this process. With little plant life, it is a vast, silent, and inactive part of the global carbon cycle. It is a land of rock and sand, and while it plays a role in the global climate by absorbing and radiating heat, it does not act as a significant carbon sink, a place where carbon is stored. Our terraforming project would fundamentally change this. By introducing vast new forests, grasslands, and wetlands to the Sahara, we would be initiating a new immense planetary process of photosynthesis. The billions upon billions of plants we would introduce would begin to draw carbon dioxide from the atmosphere, using it as a building block for their leaves, stems, and roots. This would be a massive global-scale act of carbon sequestration, a powerful new lung for a planet that is currently struggling to breathe. The Sahara would stop being a passive sun-baked landscape and become an active living participant in the global carbon cycle, a new and powerful engine of creation. The scale of this would be immense. To grasp the sheer volume of carbon we would be sequestering, let's consider a single tree. A mature tree can absorb a significant amount of carbon dioxide every year. Now imagine that number multiplied by trillions. The newly green Sahara would be a global-scale climate solution, a natural way to reduce the amount of carbon in our atmosphere. This is the beautiful and somewhat counterintuitive promise of our project. We are not just creating a new ecosystem for its own sake. We are using the very blueprint of life to help heal a global problem. This is a profound and optimistic idea, a testament to the power of nature to restore itself, if only we give it a chance. A less-known scientific fact about photosynthesis is the concept of C4 photosynthesis. While most plants use the more common C3 pathway, C4 plants, like corn and many tropical grasses, have evolved a more efficient way of capturing carbon dioxide, especially in hot, dry climates. These plants have a kind of evolutionary advantage in the kind of conditions we would be creating in the early stages of our terraforming project. We would likely use these C4 plants as our early pioneer species, the first to colonize the desert, a kind of biological vanguard specifically designed to thrive in the heat and the intense sunlight. It's a powerful reminder that the story of life is a story of adaptation and resilience, and that the answers to our greatest challenges are often hidden in the quiet, elegant architecture of cells. The philosophical implication of this is a humbling one. We are so accustomed to thinking of our grand technological solutions, our carbon capture machines, our geoengineering projects, but the truth is that the most elegant and powerful solution of all is the one that has been working for billions of years, a simple leaf. A single leaf with its intricate network of cells and its beautiful silent process of creation is a far more efficient and far more beautiful solution than anything we could ever build. Our terraforming project is not a replacement for nature. It is a collaboration with it. We are not designing a new machine. We are helping to build a new forest, a new lung for the planet. The truth is, we don't fully understand all the subtle, intricate processes that govern the global carbon cycle. There are still so many unknowns, so many feedback loops and nonlinear relationships that we are only just beginning to grasp. The mystery is not just in the science, but in the nature of life itself. The long-term effect of this new global lung would be a slower, more stable climate. The sequestered carbon would no longer be contributing to the greenhouse effect. The new forests would create their own local microclimates, cooling the air and creating more rainfall. The Sahara, a place that once seemed so barren and so dead, would become a living, breathing part of the global system, a testament to the fact that even the most desolate of landscapes can be brought back to life. But what about the challenges? The newly green Sahara would not just be a carbon sink. It would also be a source of life, and in some cases, a source of new problems. The new, abundant plant life would become a food source for a new wave of animal life. This new food web would have its own dynamics, its own chaotic and unpredictable relationships. We would have to be careful to manage this to ensure that the ecosystem we create is a stable, resilient one. We would have to be careful about the introduction of invasive species, the spread of new diseases, and the potential for a new kind of planetary scale instability. It's a powerful reminder that our act of creation is also an act of responsibility, and that we must be stewards of this new world, not just its architects. And so, as we let the image of a single leaf and its quiet, magnificent work settle in our minds, let's take a moment to reflect on the nature of our project. It is not just a triumph of engineering. It is a profound and humble collaboration with the quiet architecture of cells. We are not just building a new world. We are helping to breathe new life into an old one. Our next step is to confront the most profound and mysterious aspect of our journey, the nature of time itself. We have been thinking in terms of eons and centuries, but our next chapter will be about the strange, elusive, and beautiful nature of time and the paradoxes that await us as we move forward. We have traveled from the microscopic elegance of photosynthesis to the planetary scale of the carbon cycle, witnessing how our terraforming project would transform the Sahara into a new powerful lung for the Earth. We have seen how a single leaf, in its quiet, magnificent work, can be the most potent tool of all. Now, as our journey continues, we must confront a different kind of mystery, one that is not of matter or biology, but of the very fabric of our reality time itself. Our next chapter is about the strange, elusive, and beautiful nature of time, and the paradoxes that await us as we move forward, using the scientific concept of the twin paradox as a philosophical guide. The twin paradox is a thought experiment in Albert Einstein's theory of special relativity. It's a beautifully simple idea with a mind-bending conclusion. Imagine a pair of twins. One twin, whom we'll call the stay-at-home twin, remains on Earth. The other twin, the traveling twin, boards a spaceship and journeys to a distant star at a speed approaching the speed of light. After some time, the traveling twin returns to Earth. The paradox is this: according to special relativity, time moves slower for objects that are moving faster. So when the traveling twin returns, they will have aged less than the stay-at-home twin. For the traveling twin, only a few years may have passed, while for the stay-at-home twin, decades may have gone by. It's a powerful reminder that time is not a universal constant, but a subjective experience that is relative to an observer's motion. How does this relate to our terraforming project? The connection is not physical, but philosophical. The time it would take to terraform the Sahara, centuries, perhaps even a millennium, is a different kind of time than the eons that created the desert in the first place. The Sahara's memory, which we spoke of earlier, is written on a geological timescale, a timeline so vast that our human lives feel like a single, fleeting breath. The slow, inexorable forces of the Milankovitch cycles the drift of continents, the erosion of mountains. These are the rhythms of deep time. Our terraforming project, by contrast, would be an act of fast, ambitious time. We would be attempting to accomplish in 1,000 years what the Earth itself took millions of years to do. We would be, in a sense, accelerating a natural process, compressing a magnificent, slow-moving story into a single, human-scale chapter. This raises a fascinating and somewhat unsettling question. Can we ever truly understand a process that operates on a different timescale than our own? Are we the architects of this new world? Like the stay-at-home twin, watching our project move forward in a kind of compressed, accelerated time, while the planet itself continues its slow, patient march. A less known and somewhat counterintuitive scientific fact about time is the concept of time dilation in a gravitational field. According to Einstein's theory of general relativity, time also moves slower for objects that are in a stronger gravitational field. So, an astronaut on the International Space Station, which is in a weaker gravitational field than the Earth's surface, experiences time moving infinitesimally faster than we do. The difference is so small, it is almost immeasurable, but it is real, and it is a powerful reminder that time is not just affected by motion, but by the very fabric of space-time itself. Our terraforming project, with its new immense lakes and forests, would create a new gravitational field, a tiny, almost imperceptible shift in the fabric of space-time. It's a beautiful and somewhat mind-bending thought. Our grand ambition to change the land would also, in a way, change the very flow of time itself. The philosophical implication of the twin paradox for our project is a humbling one. It forces us to confront the limits of our own perspective. We are so accustomed to thinking of time as a linear, constant march forward. But the truth is that it is a far more elusive and far more mysterious concept. The time we spend watching our project unfold would be a kind of compressed time, a time filled with the urgency of human ambition. But the time of the Sahara, the time of the Milankovitch cycles, the time of the slow patient erosion of rock, that time would continue on, indifferent to our plans and our desires. We are, in a sense, in a conversation between two different kinds of time, the fast, anxious time of humanity and the slow, patient time of the earth. And to truly succeed, we must learn to be a part of both. We must learn to have the patience of geology and the ambition of humanity. The truth is, we don't really know for sure how our terraforming project would be perceived by the deep, patient memory of the earth. Would it be seen as a beautiful act of creation or a fleeting, insignificant moment of madness? The mystery is not just in the science, but in ourselves. The concept of time is also deeply intertwined with our own biology. Our internal biological clock, or circadian rhythm, is a kind of internal clock that regulates our sleep-wake cycle, our hormone production, and our body temperature. A less-known scientific fact is that this clock is not perfectly synchronized with the 24-hour day. It is, in a sense, a kind of internal time dilation, a reflection of the fact that our own biology is a kind of strange, personal, and somewhat wobbly clock. Our terraforming project, with its long, patient timeline, would challenge this. We would be asking generations of people to dedicate their lives to a project that they would never see the end of. We would be asking them to work not just for their own time, but for the time of their children and their grandchildren. This is the kind of long-term thinking that is almost alien to our modern world, a world where we are so focused on the immediate and the now. It's a reminder that our project is not just a scientific challenge, but a philosophical and a spiritual one. And so, as we let the mind-bending idea of the twin paradox settle in our minds, let's take a moment to reflect on the nature of our own time. The moments you are spending listening to this, the moments I am spending speaking, are a kind of fleeting, precious time. Our terraforming project, with its millennia-long timeline, is a kind of monument to a different kind of time, a time that we can only imagine. It is a testament to the idea that some things are worth doing, even if we will never see their completion. Our next step is to move from the abstract and the philosophical to the fundamental and the physical. We have been thinking about the flow of time. Now let's think about the flow of energy. We'll explore the universal hum of energy, the fundamental principles of thermodynamics, and how our new green Sahara would alter the planet's overall energy budget. We have confronted the elusive, beautiful mystery of time itself, using the twin paradox as a guide to understand the different rhythms of human ambition and geological patience. We've seen how our terraforming project would be a conversation between these two scales of time, a humbling and profound undertaking. Now let us return from the philosophical to the physical, from the abstract to the fundamental, and explore the most universal of all concepts, energy. Our next chapter is about the universal hum of energy, the second law of thermodynamics, and how a newly green Sahara would fundamentally alter the planet's energy budget. Thermodynamics is a branch of physics that deals with heat, work, and temperature, and the relationship between them. The two most important laws are the first, which states that energy cannot be created or destroyed, only converted from one form to another, and the second, which states that in a closed system, entropy, a measure of disorder, will always increase. The universe is, in a sense, a constant flow of energy, moving towards a state of greater disorder. The sun radiates energy which is absorbed by the earth, and then radiated back into space. This is the simple, elegant dance that keeps our planet from freezing solid. The Sahara, in its current state, is a powerful engine in this dance. Its vast, bright surface, with its high albedo or reflectivity, sends a significant portion of the sun's energy back into space. The energy it does absorb heats the ground, which in turn heats the air, creating the powerful convection currents we discussed in a previous chapter. It's a system of maximum entropy, a place where energy is absorbed, radiated, and dissipated, with little of it being stored or used for work. Our terraforming project would fundamentally change this. By introducing a vast green forest, we would be changing the Sahara from a high albedo energy dissipating landscape to a low albedo energy absorbing one. The dark green leaves of our new forests would absorb a much larger portion of the incoming solar radiation, and instead of simply radiating it back as heat, they would use it for photosynthesis. Photosynthesis, as we discussed, is the process of converting light energy into chemical energy, storing it in the form of sugars and other organic molecules. This stored energy would be a kind of biological battery, a massive planetary-scale reservoir of clean energy. The Sahara would stop being a place of maximum entropy and become a place of increasing complexity and stored energy. It would be an act of local entropy reversal, a temporary and beautiful defiance of the second law of thermodynamics. The philosophical implication of this is a powerful one. The second law of thermodynamics is often seen as a kind of cosmic fate, the slow, inexorable march of the universe towards a state of cold, dark, and featureless disorder. Our terraforming project, with its creation of a vast, complex, and energy-storing ecosystem, would be a kind of quiet rebellion against this fate. We would be creating order from disorder life, from barrenness, and complexity from simplicity. It's a powerful reminder that life itself is a kind of local entropy reversal, a magnificent and ongoing act of creation in a universe that is otherwise slowly and inevitably winding down. The truth is, the full scope of this energy shift is still a profound mystery. We can measure the albedo of a forest and a desert, but the intricate web of energy flows the subtle interplay between the new ecosystem and the global climate system is still a matter of scientific debate. The mystery is not just in the science, but in the very nature of life itself, in its magnificent ongoing struggle against the pull of entropy. A less-known scientific fact about energy flow is the concept of a trophic cascade. A trophic cascade is an ecological phenomenon triggered by the addition or removal of top predators and involving reciprocal changes in the relative populations of predator and prey through a food chain. For example, the reintroduction of wolves to Yellowstone National Park had a profound effect on the entire ecosystem, allowing trees to grow in new areas, which in turn helped to stabilize riverbanks and create new habitats for birds and other animals. Our terraforming project, by creating a new immense food web in the Sahara, would inevitably create a new kind of trophic cascade. The new plants would be a food source for new insects, which in turn would be a food source for new birds and reptiles. The entire system would be in flux, a kind of beautiful chaotic dance of energy as it flows from one life form to another. The long-term stability of our new world would depend on our ability to manage this cascade to ensure that it doesn't spiral out of control. It's a powerful reminder that our act of creation is also an act of immense responsibility. The newly green Sahara would also have a direct impact on the global climate. The new darker surface would absorb more solar energy, which would have a warming effect. But this warming would be offset by the cooling effect of the clouds and the increased rainfall. The net effect on global temperatures is still a matter of intense scientific debate. Some models suggest a net cooling effect, while others suggest a net warming. The truth is, we don't really know for sure. It's another example of the kind of profound uncertainty that underpins our entire project. We are not just building a new world. We are intervening in a planetary system so complex that its full response is still a beautiful and somewhat terrifying mystery. And so, as we let the image of a single leaf and its quiet, magnificent work of converting light into life settle in our minds, let's take a moment to reflect on the nature of our project. It is not just a triumph of engineering. It is a profound and humble collaboration with the quiet architecture of cells. We are not just building a new world. We are helping to breathe new life into an old one. Our next step is to confront the most profound and mysterious aspect of our journey, the nature of time itself. We have been thinking in terms of eons and centuries, but our next chapter will be about the strange, elusive, and beautiful nature of time, and the paradoxes that await us as we move forward. We have moved from the grand philosophical questions of time and the universal laws of thermodynamics to a new understanding of how our terraformed Sahara would become a magnificent energy-storing ecosystem. Now, as we delve deeper into the biological reality of our new world, we must confront a different kind of complexity: the intricate, invisible threads that hold an ecosystem together. Our next chapter is about the delicate dance of life, about symbiosis, food webs, and the profound and beautiful fragility of a nascent biological community. An ecosystem is not just a collection of plants and animals. It is a single interconnected web of relationships. Every species, from the smallest bacterium in the soil to the largest predator in the forest, plays a role. The energy that flows through the system, which we spoke of earlier, is not a simple one-way street. It is a complex, intricate dance of give and take, of predator and prey, of competition and cooperation. The stability of an ecosystem, its ability to thrive and to heal itself, depends on the strength and the resilience of these relationships. Our terraformed Sahara, in its early stages, would be a new and deeply vulnerable ecosystem, and our success would depend on our ability to help these threads of life take hold. The concept of symbiosis is a core part of this. Symbiosis is a close and long-term biological interaction between two different biological organisms. It can take many forms. There is mutualism, where both organisms benefit, like the relationship between a flower and a bee. There is commensalism, where one organism benefits and the other is neither harmed nor helped, like a bird nesting in a tree. And there is parasitism, where one organism benefits at the expense of the other. Our terraforming project would be an act of intentional mutualism. We would be bringing together plants and microbes, insects and birds in a way that would allow them to benefit from each other, to help each other grow and thrive. For example, we might introduce a species of tree that has a symbiotic relationship with a nitrogen-fixing bacterium in its roots. The bacterium would provide the tree with nitrogen, a vital nutrient, and the tree would provide the bacterium with a safe place to live and a source of energy. This is a kind of biological teamwork, a quiet, unseen conversation that would be happening at every level of our new ecosystem. A less-known scientific fact about ecosystems is the phenomenon of keystone species. A keystone species is a species that has a disproportionately large effect on its natural environment relative to its abundance. The classic example is the sea otter, which, by preying on sea urchins, prevents the urchins from destroying kelp forests. In our new Sahara, we would need to be mindful of these keystone species. We would need to introduce organisms that, while not necessarily abundant, would have a massive stabilizing effect on the entire ecosystem. Perhaps it would be a specific kind of fungus that is essential for soil health, or a specific kind of bird that helps to disperse seeds across the vast landscape. The truth is, we don't really know for sure what our keystone species would be. The mystery is in the nature of life itself, in its ability to create new and unexpected relationships. The philosophical implication of this is a powerful one. We are so used to thinking of life in terms of individuals, a single plant, a single animal. But the truth is that life is a collective, a vast and intricate web of connections. We are not just creating a new world for a few species. We are creating a new home for a vast and interconnected family of life. Our success would depend on our ability to see this larger picture, to understand that our role is not to micromanage every species, but to create the conditions for the entire family to thrive. The new Sahara would be a kind of grand experiment in collective living, a testament to the idea that true strength lies not in individual power, but in a community of relationships. The vulnerability of this new system would also be a profound challenge. In the early stages, the food web would be simple and fragile. The loss of a single species could have a cascading effect, causing the collapse of the entire system. A new disease, a new predator, or a new environmental challenge could cause the entire project to fail. We would have to be vigilant to monitor the health of our ecosystem and to be ready to intervene when necessary. This is not a project we can simply start and then walk away from. It is a long-term commitment, a kind of planetary parenting, if you will. We would be guiding this new world through its infancy, helping it to learn how to stand on its own feet. The concept of a food web. A natural interconnection of food chains is another core part of this. A food web is a kind of map of who eats whom. In a desert, the food web is simple and sparse. In a forest, it is complex and dense with multiple layers of predators and prey. Our terraforming project would be a process of building a new food web, one link at a time. We would start with the simplest organisms, the plants and the microbes, and then slowly introduce the next layer, the insects, the herbivores, and the small predators. It would be a slow, patient, and beautiful process of creation, a kind of biological sculpture. And so, as we let the image of a single invisible thread connecting two different species in a quiet, mutual embrace settle in our minds, let's take a moment to reflect on the nature of our project. It is not just a triumph of engineering. It is a profound and humble collaboration with the quiet, intricate architecture of life. We are not just building a new world. We are helping to breathe new life into an old one. Our next step is to confront the most profound and mysterious aspect of our journey, the nature of time itself. We have been thinking in terms of eons and centuries, but our next chapter will be about the strange, elusive, and beautiful nature of time and the paradoxes that await us as we move forward. We have explored the intricate, invisible threads that hold an ecosystem together, witnessing the quiet, beautiful dance of symbiosis and the fragile complexity of a new food web. We've acknowledged our role not just as architects, but as stewards of this nascent world. Now, as our journey nears its end, we must confront the most human of all questions, the ethical and philosophical implications of our grand project. Our next chapter is a reflection on the shadow of human ingenuity, about our right to change a landscape so fundamentally, and what such an act says about our relationship with nature. The idea of terraforming the Sahara is a powerful and seductive one. It is a testament to our ingenuity, our ambition, and our deep-seated desire to turn wastelands into gardens. It's a dream of a world made better by human hands. But with great power comes great responsibility, and our project raises a number of profound ethical questions. Do we have the right to change a landscape so fundamentally? Is the Sahara, in its current state, a mistake of nature that we have a duty to fix? Or is it a beautiful and unique ecosystem in its own right, one that we have a duty to preserve? This brings us to a core philosophical concept known as environmental ethics. Environmental ethics is a branch of philosophy that considers the moral relationship between humans and the natural world. It asks questions like, do non-human organisms have intrinsic value? Or are they only valuable insofar as they are useful to humans? Is it wrong to cause the extinction of a species, even if it is not directly useful to us? Our terraforming project would be a kind of grand experiment in environmental ethics. We would be making a profound, irreversible decision about the value of the Sahara in its current state. The desert, with its unique and highly adapted species, its ancient geological history, and its role in the global climate, has a value that is difficult to quantify in purely human terms. A less-known scientific fact is that the Sahara is home to a number of unique and fascinating species, from the fennec fox with its oversized ears to the Saharan cheetah, one of the rarest big cats in the world. Our terraforming project, in its early chaotic stages, could cause the extinction of these species, a permanent loss of a kind of biological memory that can never be recovered. The philosophical implication of this is a humbling one. We are so accustomed to thinking of ourselves as the masters of our own destiny, the shapers of our own world. But the truth is that our planet is not just a resource for us to exploit. It is a living, breathing system with a deep history and an intrinsic value that is independent of our needs and our desires. Our terraforming project, if it is to be a moral and ethical one, must be an act of stewardship, not an act of conquest. We must approach the Sahara not as a blank canvas for our ambitions, but as a living ancient landscape that we are entering into a long and patient conversation with. The truth is, we don't really know for sure what the long-term ethical implications of our project would be. The mystery is not just in the science, but in ourselves. Are we wise enough and humble enough to make a decision of this magnitude? The question of ownership and control is another ethical challenge. The Sahara is not an empty, uninhabited wasteland. It is home to millions of people, a diverse collection of nomadic tribes and settled communities who have lived in the desert and on its edges for millennia. They have a deep spiritual and cultural connection to the land that is entirely different from our own. A terraformed Sahara with its new lakes, rivers, and forests would be a new world for them as well. It would bring with it new opportunities, but it would also bring new challenges. It would disrupt their traditional way of life, change their relationship with the land, and force them to adapt to a new and unfamiliar world. Do we have the right to impose this change on them, even if our intentions are good? This is not just a scientific question. It is a question of justice, of autonomy, and of respect for the cultures and the lives of others. The answer, perhaps, is that there is no simple answer. This is where the concept of intergenerational equity becomes important. Intergenerational equity is a concept that deals with the fairness of resource allocation and the moral obligations of one generation to another. Our terraforming project, with its centuries-long timeline, is a kind of grand intergenerational contract. We would be making a decision today that would have profound and irreversible consequences for generations to come. We would be making a decision for our great-grandchildren and their great-grandchildren, and we would be doing so without their consent. The question is, do we have the right to do that? Do we have the right to commit future generations to a project of this magnitude, one that could bring with it both great benefits and great risks? The answer is a complex one, a tangle of moral, ethical, and philosophical considerations that we are only just beginning to unravel. And so, as we let the image of a single fennec fox, a tiny, magnificent creature with oversized ears, settle in our minds, let's take a moment to reflect on the nature of our project. It is not just a triumph of engineering. It is a profound and humble act of ethical reflection. We are not just building a new world. We are asking ourselves what kind of world we want to live in and what kind of legacy we want to leave behind. Our next step is to confront the most profound and mysterious aspect of our journey, the nature of time itself. We have been thinking in terms of eons and centuries, but our next chapter will be about the strange, elusive, and beautiful nature of time and the paradoxes that await us as we move forward. We have wrestled with the profound ethical questions of our project, questioning our right to change a landscape and contemplating our role as stewards rather than conquerors. We've seen how our human ingenuity casts a long shadow, a shadow that touches on justice, responsibility, and the deep intrinsic value of the natural world. Now, as our journey nears its end, we must confront a final, beautiful paradox, the nature of memory. Our next chapter is about the memory of a sand dune about entropy and the idea that even a terraformed Sahara would retain the ghost of its former self. Entropy is a core concept of thermodynamics, a measure of disorder in a system. The second law of thermodynamics, which we touched on earlier, states that in a closed system, entropy will always increase. The Sahara, with its vast, featureless landscape of sand and rock, is in a state of high entropy. Its energy is dissipated, its complexity is low, and its memory is written in the slow, inexorable process of weathering and erosion. The shifting sand dunes are a kind of geological forgetfulness, a constant process of erasing the past. Our terraforming project would be an act of local entropy reversal, an act of creation that would bring order, complexity, and a new kind of memory to the desert. The new forests, with their intricate food webs and their complex nutrient cycles, would be a low-entropy system, a magnificent and ongoing act of creation in a universe that is otherwise slowly and inevitably winding down. But would the Sahara truly be forgotten? Would its memory be erased forever? This brings us to a less-known scientific fact about memory, not human memory, but the memory of a system. The Sahara's memory is written in its geology, in the ancient riverbeds that lie buried beneath the sand, in the layers of sediment that record its lush past, and in the chemical composition of its rocks. Our terraforming project, with its new lakes and rivers, would not erase this memory. It would simply bury it under new layers of sediment and new life. The ancient riverbeds would still be there, but they would now be under a new living landscape. The memory of the desert would not be gone. It would simply be sleeping, waiting to be discovered by a future generation of geologists and archaeologists. The Sahara would become a palimpsest, a kind of ancient scroll on which we have written a new story, but the old story would still be there, a faint, beautiful echo beneath the new. The philosophical implication of this is a beautiful and a humbling one. Nothing is ever truly erased, only transformed. The energy that once heated the sand would now be stored in the leaves of a tree. The carbon that once filled the air would now be a part of the wood of a forest. The dust that once fertilized the Amazon would now be a part of the soil of a new ecosystem. The Sahara's memory, in a sense, would be transformed from a memory of desolation and heat to a memory of life and growth. It would be a new kind of memory, a memory of a journey from barrenness to abundance. This raises a fascinating and somewhat unsettling question. Is a memory of life more valuable than a memory of desolation? Is our act of transformation an act of moral improvement, or is it simply an act of change with no inherent moral value? The truth is, we don't really know for sure. The mystery is not just in the science, but in our own values. This idea of memory and entropy is also a beautiful metaphor for our own lives. We are all, in a sense, a kind of low-entropy system, an intricate web of complexity and order in a universe that is otherwise slowly winding down. Our lives are a constant struggle against the forces of entropy, a constant process of creating order from disorder. And in our lives, just as in the Sahara, nothing is ever truly erased. The memories we have, the relationships we build, and the love we give, they are not gone when we are gone. They are simply transformed, a faint, beautiful echo in the lives of those we have touched. The Sahara, in its transformation, would be a kind of grand planetary scale version of this process, a testament to the idea that life is not just a triumph against entropy, but a beautiful and ongoing conversation with it. The ghost in the machine is not just the chaos of our future, but the memory of our past. Even after centuries of terraforming a new lake, could be a reminder of the ancient seabed it now occupies. The new fertile soil could still contain the grains of sand that were once a part of a dune. The entire landscape would be a kind of living, breathing museum of its own history, a testament to the fact that even the most dramatic of changes cannot erase the past. The Sahara would not be gone. It would simply be a part of a new, more complex and more beautiful story. The ghost of the desert would be the quiet, beautiful echo that gives this new world its depth and its meaning. And so, as we let the image of a single grain of sand, now a part of a new fertile soil, settle in our minds, let's take a moment to reflect on the nature of our journey. We have traveled through time and space, from the grand quiet rhythms of the cosmos to the intricate microscopic architecture of a single cell. We have confronted the humbling reality of our own limitations, the profound mystery of a system we can only partially comprehend, and the beautiful ethical weight of our own ambition. Our next and final step is to bring our journey to a peaceful close, to let the image of a new green Sahara fade into the quiet, and to offer a gentle final reflection on the legacy of our imagined world. We have arrived at the end of our journey, a journey that began with a whisper of sand and ends with the quiet hum of a new living world. We have traveled through deep time and microscopic space, from the grand quiet rhythms of the cosmos to the intricate invisible threads of an ecosystem. We have confronted the humbling reality of our own limitations, the profound mystery of a system we can only partially comprehend, and the beautiful ethical weight of our own ambition. Our final chapter is a reflection on the completion of our hypothetical journey, a look at the long-term stable state of a green Sahara, and a poetic gentle close to our story. After centuries of painstaking work, the Sahara is no longer a desert. The vast sandy expanse is now a magnificent tapestry of green and blue. The great inland seas we imagined, fed by desalination plants and canals from the ocean, have become freshwater lakes, their salinity slowly diluted by 1,000 years of rainfall. The pioneer species which we spoke of so long ago have given way to a magnificent forest, a biome of immense biodiversity that stretches across millions of square kilometers. The global atmospheric and oceanic systems, which we so feared would be thrown into chaos, have found a new equilibrium. The planet has in its own magnificent and patient way adapted to our changes. The new green Sahara is now a stable part of the global system, a new lung for the planet, a new heart for the world. The long-term state of this new world would be a kind of grand planetary peace. The new forests would be a massive carbon sink, absorbing billions of tons of carbon dioxide from the atmosphere every year, helping to stabilize the global climate. The new lakes and rivers would be a source of life for millions of people, providing clean water and new opportunities for agriculture and trade. The new ecosystem would be a testament to the resilience of life itself, a magnificent and ongoing act of creation. The ghost of the desert would still be there, of course, a faint echo in the geological record, a beautiful memory of a world that once was. But it would be just that, a memory. The new world, with its vibrant life and its magnificent forests, would have its own story to tell, a story of hope, resilience, and the quiet, patient triumph of life. The philosophical implications of this final state are as profound as the scientific ones. We would have proven on a planetary scale that our ingenuity can be a force for good, that we are capable of not just destroying our world, but of healing it. We would have moved from a philosophy of conquest to a philosophy of stewardship, from a relationship of domination to a relationship of collaboration. The terraformed Sahara would be a kind of monument to this new philosophy, a testament to the idea that we can be a part of the natural world, not just a separate and destructive force. The truth is, the full scope of this long-term stability is still a profound mystery. We can only imagine what this new world would be like, what new species would evolve, what new cultures would emerge, and what new stories would be told. The mystery is not just in the science, but in the future itself. A less-known scientific fact about ecosystems is the concept of a climax community. A climax community is a relatively stable, mature, and self-perpetuating ecosystem that is in equilibrium with its environment. Our terraformed Sahara, after 1,000 years of ecological succession, would have reached a kind of climax community. The forests would have a stable mix of species, the food webs would be complex and resilient, and the ecosystem would be able to heal itself from disturbances like fires and floods. It would be a kind of planetary masterpiece, a magnificent and ongoing act of creation that no longer requires our constant intervention. We would have fulfilled our role as stewards, and the new world would be able to stand on its own feet. And so, as we let the image of a green and vibrant Sahara, a place of peace and abundance, settle in our minds, let's take a moment to reflect on the nature of our journey. We have traveled a long way from a whisper of sand to a shout of life. We have confronted the vastness of the universe, the depths of the ocean, the currents of the air, and the quiet architecture of a single cell. We have asked ourselves what it means to be human, what it means to be a part of this magnificent, ongoing story of life. And in the end, the answer is simple. It means to be a part of the conversation. The journey is now complete. The grand story of a green Sahara is no longer a question, but a quiet, beautiful thought. The images of sand and water of chaos and creation of deep time and fleeting moments, they are all a part of a single continuous thread. Let them gently drift away now, like leaves on a slow-moving river. The story we've told is a grand one, but the moment you are in is a simple and quiet one. The sound of my voice, the warmth of your covers, the soft whisper of the night. These are the truths of your present. The sands of the Sahara are now a part of a different world, a world that exists only in our shared imagination. I'd like to gently ask one last time, where is the place you're staying now? The time in that place at this very moment, how is it flowing? Let the words of our story gently brush past you and let your mind slowly fade into the soft, comforting silence of the night. Sleep well, my companion. Wherever and whenever you are, sweet dreams.